Okay, hello and welcome everyone. In this series of videos, or in this video, I'll have a series of exercises that are going to essentially look at calculus applications to perfect competition and cost curves, going basically from the principles of economics level up to the intermediate micro level. So anyway, the first exercise, consider a price-taking firm where price is equal to marginal revenue. Not a typo. What this refers to is, remember, for the competitive market, the price is generated by the interaction of supply and demand, and then all individual firms are just going to take that price as given. Hence, selling an additional unit is going to fetch exactly MR, right? The marginal revenue is going to be exactly the market price in a competitive market. And then what is that market price? We're going to say it's $25. Suppose the firm's costs are given by 0.25 Q squared plus 10 Q plus 25 or 250, where Q is the amount of output. Find the firm's fixed cost, variable cost, marginal cost, average variable cost, and average fixed costs. What quantity do we produce in the short run? What quantity do we produce in the long run to maximize profits? All right, so the first part, fixed costs, that's just the part that is invariant to output. It's just the constant. It's the part that doesn't change with output. So if you produce 0, it's the same as producing 1,000,000. Your fixed cost either way is 250. Variable cost, that's the portion that does vary with output. So it's the 1/4 times Q squared plus 10Q is the variable cost. To make this average variable cost, you divide this by Q. So average variable cost is dividing by Q. That's going to be 1/4 Q plus 10. Average fixed cost is dividing your fixed cost by Q. So 250 divided by Q. And then my marginal cost, that's just the first derivative of the total cost function. So that's going to be 2 times 1/4 is 1/2. Reduce this power by 1. So it's going to be 1/2 Q plus 10. Notice the marginal cost and the average variable cost have similar shapes. And here, this has to happen because we have a quadratic total cost. Here, marginal cost has twice the slope as average variable cost. And what this means is, of course, our marginal cost is steeper. It's going to cross average variable cost at the point 0,10, which has to happen because we know marginal cost has to cross average variable cost and average total cost from below at their respective minimums. And the minimum of average variable cost is going to be 10. Minimum marginal cost, 10. Anyway, so short run output, how do we find this? Well, let's find where marginal cost is going to be equal to price. So we'll set 25 equal to marginal cost, which is 1/2 Q plus 10. Okay, so moving the 10 to the other side, we have 15 is equal to 1/2 Q, or 30 is equal to Q. This is just what the firm will produce if they're going to produce a positive amount of output. Maybe they want to produce 0. So we have to compare. There's two things we could do. One is we could look to see what is the average variable cost associated with producing 30 units of output. And if price is lower than average variable cost, if the average variable cost of producing 30 units of output is more than 25, we know they shut down and they would not produce in the short run or the long run. Or we could just calculate profits directly. Let's compute profits where quantity is 0. That's easy. It's going to be negative 250. If they don't produce anything, they're responsible for their fixed cost. So it'd be minus 250 if they produce 0. What if they produce 30? Well, let's just evaluate profits. This part's revenue. Output price times or market price times output, 25 times 30. And then this is just minus the cost function portion. Okay, so we've got that. And then we find that profits are going to be 750 minus the quantity, 225 plus 300 plus 250, or that's going to be minus 25. Okay, good. So minus 25 is a loss, which tells us probably in the long run, they're not going to want to be in the market. In the short run, yeah, they'd rather produce and lose 25 than not produce and lose 250, right? Because they're covering their average variable cost, they're not covering their fixed cost. So what do we know about the long run? Well, not a whole lot. So we know that they want to produce in the short run, exit in the long run. If something were to change, if there's enough exit so that the market price would rise, maybe they'd stick around in the long run. But without knowing exactly what the long run situation looks like, it's hard to say, other than this firm's probably going to want to shut down in the long run because they're already making losses in the short run. All right, consider a cost function and then show using calculus that the point where the minimum of average cost function is exactly where marginal cost equals average cost. All right, so we'll just want to derive the first order condition for the average cost to be a minimum. Just take average cost, take the derivative with respect to output, and you're done. So we got it. So here is average cost. It's just C of Q divided by Q. Let's take that derivative. Well, I don't want to do the quotient rule. I want to do the product rule. So I'm going to rewrite this as cost times Q to the minus 1, right? That's the same as this. right? And then this just means I'm going to differentiate what's inside these parentheses. All right, so when I take this derivative, it's going to be c prime. And then this q comes along for the ride. And then I'm going to write this as this c of q coming along for the ride. I'm going to differentiate this. So it's going to be minus 2 q to the, or minus 1 q to the minus 2. So this is my negative from this right here. That's where this switches to negative. And then this q squared is from reducing this power by 1. Okay, well, as we're staring at that, this looks a lot like marginal cost minus average cost. It's just that we got this extra q floating around there. Let me factor out that q. Matter of fact, we can multiply it through to the other side if we wanted to, and we're going to end up with our condition marginal cost minus average cost equals 0 is our first order necessary condition. That's what this is doing. I think right here, this makes my head hurt to try to read this line right here. So I think this probably a typo. I don't know. Or I don't know. Maybe I was coming up with I was doing something at the time that I thought was way more clever than I'm thinking it is now. So I think this is the more intuitive path. So, and then this definitely right here, this needs to be, so if we're going from this line to this line, definitely we're going to move the c of q to the other side and then divide through by q. So we have to get average cost. So this is definitely missing a q there. So anyway, so our condition for minimizing average cost is marginal cost is equal to average cost. That's what this is saying, because this is equal to 0 by virtue of this being our first order condition, right? First derivative set equal to 0 is the first order condition for a maximum or a minimum. That's what we did here. And that's telling us that we found this point right here, the minimum of average cost. And that is where marginal cost equals average cost. That's what this is saying. All right, I think that's cool. More typically, marginal cost curves are not linear, but instead U-shaped. In this case, it can happen the marginal cost crosses the marginal revenue, crosses the demand at 2 points. What's going to be the profit maximizing level of output and why? So is it going to be Q1 or Q2? Well, the Econ 101, the principles of econ logic is let's compare marginal benefit to marginal cost. Once we get to Q1, if we produce a little bit more, marginal benefit, the price, is bigger than the marginal cost. So we ought to actually keep producing. Marginal benefit remains above marginal cost until we hit here. Now marginal cost is higher than marginal benefit, so we'd stop at Q2. So that'd be like the non-calculus way to show this. Just compare at the different quantities where marginal benefit exceeds marginal cost. Whenever marginal benefit is bigger than marginal cost, you do more of the activity. In this case, marginal benefit's marginal revenue, the price. If price is bigger than marginal cost, you produce more. And that's an argument for going from Q1 up to Q2. There's a calculus version, which I like better. So calculus version is, let's write out profit. Profit is pi of Q. Economists use pi for profit because we use P for price and for inverse demand, and there's too many P's flying around, so we use profit or pi for profit. Profit is going to be revenue minus cost. Now let's think about what's necessary to maximize profit. Take a derivative with respect to output. Okay, so this is dr dq, this is dc dq, and then evaluate at the optimal makes this our first order condition. Well, let's take a second derivative. So I'm going to differentiate this thing again. So I'm going to take another derivative with respect to q. So this is going to be the second derivative of the revenue portion, the second derivative of the cost portion. And I wish I didn't write it this way. This right here should follow below rather than next to it. But what this is doing is saying, wait a second, why am I taking the second derivative of revenue? Why don't I just write this in familiar form? Why don't I write that as the first derivative of marginal revenue? Right? Because this right here is MR. dr dq is MR. And when I take the derivative again, I'm taking the derivative of marginal revenue. Similarly over here, dc dq is marginal cost. So when I take the second derivative of marginal cost, when I take the second derivative of cost, why don't I just think of that as the first derivative of marginal cost, which is another way to refer to the second derivative of the cost function. So brilliant, right? Yeah, it is. So all right, so we have our derivative of marginal revenue minus the derivative of marginal cost is less than 0. This is our condition for this is our sufficient condition for a maximum. Now as we're staring at this, we're like, wait a second, can move this to the other side. And what this is telling us is our sufficient condition for a maximum is that our derivative of marginal cost is bigger than our derivative marginal revenue. But wait a second, marginal revenue is just a constant. It's just the market price. So dmr dq, it's 0. Right? Think of what derivatives are doing. Derivatives are saying, how is the function changing? right? Derivatives, whenever you see derivative, you want to think of rate of change. How's marginal revenue changing? It's not, right? So this is 0, which has a nice interpretation. So now if I replace this left-hand side with 0, my sufficient condition for a maximum is just that my derivative of marginal cost is positive, or that marginal cost is upsloping. Sure enough, that's what this is, right? We have 2 candidates for a maximum. This is the maximum that we want because here marginal cost is upward sloping, right? Our sufficient condition for the true maximum is marginal cost upward sloping. All right. So the last line says a sufficient condition for a competitive firm to be maximizing profit is for marginal cost to be upward sloping at the optimal quantity. All right. So I scrolled up, and here I redrew my picture down here, and then I didn't look ahead. So anyway, rather than scrolling up, I should have just went down. Anyway, so next thing, consider a perfectly competitive firm with the following cost curves. I'll show you those cost curves. It's these. That's obnoxiously large, so I'll make it smaller. All right, so it's these cost curves. Good. Now this is obnoxiously small, so I'll make it bigger. All right. Draw and label the firm supply curve. What profit does a firm attain at these prices? And will they produce the quantities Q1, Q2, and Q3 at which prices? Okay. Well, the firm supply curve is just the marginal cost curve above average variable cost, right? Indeed, this is a supply curve. What do supply curves do? They relate price and quantity, right? Quantity supplied. So you give me a price, I give you the quantity. Oh, we can do that with marginal cost. I give you a price, you give me the quantity, right? Price, quantity. What if the price is down here? Quantity 0, right? So indeed, I've shaded in red the firm supply curve. It's the portion of the marginal cost curve that lies above average variable cost curve, and then I guess this portion of the axis. So that is the supply curve. What about these prices? Well, our break-even point is the minimum of average cost. That's where profits are 0. Our shutdown point is the minimum of average variable cost. That's where below here there's economic losses below average cost, but once you get below average variable cost, you're no longer covering like your ingredients or your labor costs. So this is like a cookie factory that's taking milk, sugar, eggs, and making cookies that taste worse than those components alone. So you should probably like not operate your cookie factory then. Anyway, so profits are going to be positive only above P5. They're negative below, and then this less than means like super negative. They're really negative down here. These are like really big losses. So in the short run, the firm would make positive economic profits here, 0 economic profits at P5. It would operate between P3 and P5, though it would be making a loss, and then it would shut down immediately for prices lower than P3. What about these quantities? It would never produce Q1 because that's below average variable cost, right? That's below the minimum of average variable cost. So the firm would never produce Q1, even though that's certainly a point where price can equal marginal cost. It would produce quantity 2 if and only if the price was P3. And then what about quantity 3? That's what it'll produce if the price is P5. Okay, supply is marginal cost above average variable cost, and this comes as a result of the shutdown rule, which is shut down if the price is less than average variable cost. And here's the solution I had written out, although I like the one I just went over way better. So I'll leave this here for a second if you want to stop the video, whatever. So, all right, then we want to think, I'm going to give a collection of market demand, market supply curves, and a collection of individual prices and marginal revenues. We want to see how they're related. So if S naught is the initial supply, what's the effect of entry on market supply, market price, individual firm demand, and individual firm supply? Entry is going to increase market supply. It's going to drive down the market price. It's going to lower the individual firm's demand, and then we'll walk down the individual firm supply curve. So the increase in market supply is going to give us a decrease in market price, decrease individual demand, decrease individual supply. If there's more firms in the market, each individual supplies fewer units. As the lower market price brings us to the lower quantity from the price equals marginal cost calculation. All right, there's a graph that needs to go with this. So it's this. So we can visualize if we're at S naught and we have entry, we go to S1. Look what happened to the equilibrium. It started here, ended here. So we've got the market on the left, single firm on the right. This single firm, when lots of other firms enter and supply goes from S naught to S1, lots of other firms enter, and this firm sees its demand curve, its margin revenue curve shift downward to be D1, right? And then think about the individual firms cost curves, like average variable cost curve goes like this, the average or marginal cost curve goes through here. Basically, the price line has fallen relative to that firm's supply or cost curves. Okay, so perfect competition and cost curves. This firm has the following total cost curve. TC of Q is equal to 20 Q squared plus 2Q plus 100. What's the firm's supply curve for operating in this industry? Oh, well, we're going to first have to find average variable cost and then find the quantities that are going to be bigger than corresponding to where price equals marginal cost higher than average variable cost. All right, so the first thing we want to do, we have our total cost. Let's find variable cost. That's going to be the 20Q squared plus 2Q. That's the part that varies with output. All right, fixed cost is 100. I needed an equals here. Fixed cost is 100. Marginal cost is the derivative of the total cost function. Right, so that's going to be 40Q plus 2. Right, 40Q plus 2 is marginal cost. For a perfectly competitive market, the firm sets price equal to marginal cost. Technically, the firm is going to set marginal cost equal to price, which means we're going to compare price to 40Q plus 2. And the firm's supply curve is the portion of marginal cost lying above average variable cost. So we know average variable cost is going to be variable cost divided by Q, which gives us 20Q plus 2. Notice the relationship. So marginal cost is P is equal to 40Q plus 2. Average variable cost is 20 plus 20Q plus 2. So marginal cost is twice as steep. Indeed, it's going to cross average variable cost from below at its minimum. The minimum is going to be at the 0.02. Anyway, so I say that here, the shutdown price of the firm is the minimum price of average variable cost. That's the intersection of average variable cost and marginal cost. The quantity where this happens, that was just a quantity of 0 corresponding to a price of 2, right? We can see that this is the vertical intercept is 2. That corresponds to a quantity of 0, right? Quantity of 0, then the price is 2. Quantity of 0, price is 2. So the supply curve is going to be price is equal to 40Q2 or 40Q plus 2, the marginal cost, where price is greater than 2. Right? So this is the line. Now we have to stipulate that price is bigger than 2 because this line goes infinitely in both directions. Right? We're only interested in the portion where price is going to be positive. Where price is going to be. So we're interested in the so what I said is correct if you think about the graph. More properly, we're interested in the portion of marginal cost that lies above average variable cost, and this is what we need to say to get that. All right, draw the picture. Picture's pretty easy to draw. Marginal cost and average variable cost are upward sloping lines emanating from the 0.02. Supply curve is the entire portion of marginal cost because marginal cost is everywhere above average variable cost. Specifically, at the quantity of 0 is where they cross, and then the supply curve is the line 40Q plus 2, where price is greater than 2. And I don't think I drew the picture. Well, what's the picture going to look like? It's just going to be a straight line corresponding to, so the marginal cost is going to be a straight line with a slope of 40 emanating from the 0.02, and average variable cost is going to be a straight line with a slope of 20 emanating from the 0.02. All right, and what was this doing? Oh, I did draw the picture. So I wrote out these solutions and then several days ago, and I didn't have time to make the video. So now I have time to make the video, but I forgot what I had written out for us. All right, so this is going back over that exercise. Here is total cost, here is variable cost, here is marginal cost, there is fixed cost. Average variable cost, let's just take the variable cost divided by output. I don't know why I have 2 there. And then, so then where's price equal to marginal cost? This is going to be marginal cost equals or is bigger than average variable cost. And this tells us when quantity is positive, then marginal cost is bigger than average variable cost. So our supply curve is technically 40Q plus 2 when price is greater than 2. So I don't know if that was helping anyone. So here's what the picture looks like. That's what we all cared about. So very good. All right. Question number 7. Anne runs a firm that sells multi-passes to intergalactic cruises in a competitive market. So good. Short run cost function is given by Q squared plus 25Q plus 144. Market price is 75. How many units will Anne produce? All right. Well, to maximize profit, we want to find where d pi dq is equal to 0. So I can write out profits. This is revenue, market price times output. This is representing the costs. Take the derivative. So it's going to be 75 minus 2q minus 25 is equal to 0. This 144 is a constant with respect to differentiating here. So solving, our profit maximizing candidate output is 25. We have to determine that they'd rather produce 25 than 0. If they produce 0, their profits are going to be negative 144. They lose their fixed cost. What if they produce 25? So we check that. Oh, we weren't asking that. Here we're just saying how many units would they produce. Well, I don't know. To be really, yeah, so I should have, because I was a little bit lazier than I should have been. I should have actually shown, so there's two steps, right? You have to know. So I didn't actually answer the question. So there's two steps here. Once you found out what the candidate positive amount is, you have to determine would they rather produce that than 0. So we have to compute our profits at a quantity of 25. Or we could look to see is the price bigger than average variable cost of producing 25 units? So you could do that as well. All right, well, I don't want to stumble through this video, so I'll leave that as an exercise. What price will Ann earn 0 economic profits? So where's profit going to be equal to 0? Well, there's a couple different ways to do this. One thing is recognizing that a 0 economic profit point, the break-even point, is where marginal cost is equal to average cost. So we have our marginal cost. It's 2q plus 25. That was just from the first derivative, 2q plus 25 of our cost function. We have our average cost. That's just take our cost divided by q. So q squared divided by q is q. 25q divided by q is 25. 144 divided by q is 144 divided by q. All right, so we'll set this equal to each other, and then solving, we'll find we need a quantity of 12. What'll happen? Well, if we're following this logic here, the 25s drop out. I'll get a q equal to 144q, or q squared is equal to 144. So q is equal to 12. Square root of 144 is 12. All right, the average cost associated with producing 12 units and the marginal cost associated with producing 12 units, it's 49. So profit equals 0 when the price is equal to 49. All right, so price is equal to 0. And, okay, so we actually solved part A, right? If the 0 profit line is where price is equal to 49, and up here, price is equal to 75, then they're definitely making profits in part A. So, all right, cool. If price falls below the level we found, will Ann shut down? Not immediately, right? As long as price is bigger than average variable cost. So that's my comment. No, Ann doesn't shut down when the price is below minimum of average variable cost, right? Average variable cost is going to be Q plus 25. The minimum occurs at a price of 25. So Ann won't shut down until price is below there. Long run scenario with entry and exit. What will be the long run market price? Well, let's see. We've got currently economic price or profits because price was 75. So we expect there's going to be entry, right? I mean, intergalactic passes. I mean, for sure, Elon Musk is going to be a major competitor here. So price is going to fall. We expect the long-run competitive equilibrium to fall to the minimum of average cost of the most efficient firm. If it's this firm, cool, they'll stay. If there is more efficient firms amongst them, then this firm will have to exit. So that's my comment here. If the most efficient firm is Ann and other firms like Ann, then the price will match Ann's break-even point, 49. If not, then the long-run price will fall below Ann's short-run break-even point, and Ann will have to exit. Good. All right, question 9. Suppose the cost function for a firm is given by 60 plus 4q plus 2q squared. Assume the firm sells output in a perfectly competitive market. Other firms in the industry sell output at a price of $20. At what level of output should the firm optimally produce and for what profits? All right, well, we just want to think about maximizing profit here. So let's see, profit is going to be the revenue, so 20 times q, minus 60, minus 4q, minus 2q squared. That's this. Take the derivative, it'll be 20 minus 4q, minus 20 minus 4 minus 4q. So this 60 goes to 0. It's a constant with respect to, when we differentiate with respect to q. This 4q, the derivative is just the coefficient. It's 4. And then this is 2 times 2. So minus 4q. And then solving, we find, q has to be equal to 4. To find profit, to find if they actually want to produce here, we have to compare what's going to be the profit where quantity is equal to 0. Well, when quantity is equal to 0, We lose 60. That was our fixed cost. What's going to be our profit when we actually produce? Well, that's this right here. So profit is going to be 20. Revenue times output, that was 4, minus 60 plus 16 plus 2 times, or plus 32. So our profit is going to be 80 minus 108, or minus 28. Minus 28 doesn't look good, but it's bigger than minus 60. So this firm's going to want to produce in the short run, exit in the long run. Let's see. Now reconsider the original situation instead with fixed costs equal to 20. So rather than having 60 here, we have 20. So what changes? What changes is this is 20, not 60, right? This was 60. Now our fixed costs are 20. Okay. So that's going to have the effect on changing this portion right here. So now the whole rest, I mean, the optimal outputs candidate is still 4, but profits now are going to be 80 minus 68 is equal to 12. All right, so now we have positive economic profits, and that will persist in the short run until there's entry to drive those profits to 0. What effect, if any, does the reduction in fixed costs have on the competitive firm's short-run profit production decision? Well, it's irrelevant, right? The fixed costs are irrelevant for short-run production. The competitive firm is only going to care if price is bigger than average variable cost, and in this case it is. All right, let's see. Reconcile the profit levels in A and B with our understanding competitive firms make 0 profits. Well, you can have positive profits and you can have negative profits in the short run. In the long run, we expect that there's going to be 0 economic profits. At what point will a competitive firm shut down? So we have to find the shutdown point. Shutdown rule is price is less than average variable cost. So in this case, the price of 4 is our shutdown point. So what was our marginal cost was 4 plus 4Q. Our variable cost, let's see, let me go back to the beginning. So our variable costs were 4Q plus 2Q squared. So our average variable cost is 4 plus 2Q. And so we're interested in 4 plus 2Q as average variable cost, and we're going to evaluate at the quantity of 4 that we found. And so it'll be 4 plus 8, it'll be 12. So the firm wants to shut down. Let's see, break-even point, what is this? Oh, no. So I was doing something else here. Oh, no. So, all right. So what we're trying to do is we're trying to find the minimum. All right. So what I just did a second ago, so I was like, is this firm going to shut down? No, it's not, because I checked price compared to average variable cost at the quantity of 4. That's not what we're doing here. Here we just want to know when will this firm shut down. So now we just need to minimize average variable cost. So to minimize average variable cost, we'll recognize that marginal cost is going to cross average variable cost from below at its minimum. Let's set marginal cost equal to average variable cost. And that happens at a quantity of 0 and a price of 4. So made that way harder than it needed to be. All right. So now we want to consider this collection. So suppose the cost function of the firm is given by C of Q is equal to 180 plus 4Q plus Q squared. Assume the firm sells output in a perfectly competitive market, and other firms in the industry sell output at a price of 40. So this is the market price. What level of output should the firm optimally produce, and for what profits? Well, set marginal cost equal to price. So 40 equals marginal cost 4 plus 4Q, or we get a quantity of 9. Now we need to verify that the profits at producing 9 are bigger than the profits of producing 0. Oh, they are. Right? So our profits of producing 9 are minus 18. Our profits of producing 0 is minus 180. Now reconsider the original situation, instead with fixed costs equal to 160. Price is equal to marginal cost. So we still get a quantity of 9. Then computing our profits, we get profit is equal to 2. Right? So we compute the profits associated with producing an output of 9. And we end up getting profits of 2. Notice what I did? When I was writing up my solution, I had the solution boxes switched. And for the purpose of the video, it's easier to redo the order than to try to copy and paste and move. So with GoodNotes, I can take screenshots of the printed solution and move things around, but that would have been a mess. So sorry if you're following along with the real version. You just look at these. You just switch those two solutions. Same problem. Okay, so what effect, if any, does the increase in fixed costs have on the competitive short-run decision? We just answered that. It's irrelevant. All they care about is price is bigger than average variable cost. What firm do they shut down? So we did this already. It's the same. I mean, it's the same problem. I'm so bored. I'm so bored of this. All right, so we'll compare marginal cost to average variable cost and then solve for the quantity that makes them equal. And that's what we did for the previous problem. It's the same problem. All right. How many more of these do I have? Oh, one more. All right. Consider the long-run outcome in a particular market where the firm has the following long-run average cost function. So average cost is going to be 5q squared minus 10q plus 30 with a long-run marginal cost of 15q squared minus 20q plus 30. Suppose the total market demand is going to be 5,010 minus 200 times the price. Good. In the long run, the firm wants to produce where price equals marginal cost equals average variable cost. Well, we've got average cost. We can get marginal cost, or we have marginal cost. We'll set those equal. This is average cost. This is marginal cost. And then solving, we find a quantity of 1. Okay. So that's how much we'd produce to have 0 economic profits. What's going to be the long run price? Well, so price is equal to marginal cost. Each firm is producing where price is equal to marginal cost. So marginal cost of producing 1 unit compared to the price. That's what we're doing here. Right? So here we said, oh, in the long run equilibrium, how much are they going to produce? They'll produce where there's 0 economic profit. So we want price is equal to marginal cost is equal to average variable cost. Actually, we want to focus on this. Marginal cost is equal to average variable cost, and we find the quantity that makes it happen. It was 1. Now let's find the associated price by exploiting the fact that it's going to be equal to that price. So we'll evaluate marginal cost at the quantity of 1, and we find a price of 25. Now, how many firms are going to serve the market in the long run? This is a little weird. So how does this work? Well, suppose our total market demand was 5,010 minus 200p. So we find the total market demand at the equilibrium price and then divide this by the optimal production per firm. All right, so here's our market demand. Our total market demand at the equilibrium price of 25. Total market demand is going to be a quantity of 10. Right? So we have a quantity of 10. Each firm's optimally producing 1 unit, so we need 10 firms. So what's going on here? Well, we found the market price. We found the output per firm. Now we just have to figure out, given the market demand, what's the quantity demanded at that price. It's 10. Each firm's producing 1, so we need 10 firms, which is brilliant. Like, I really like this question because this is pulling together a lot of important economic concepts. And it's a type of thing, as are a lot of these exercises, where you want to kind of give some thought about what the solution needs to be before you run to the algebra. Because if you look at this one, you're like, how many firms serve the market in the long run? If you just look at that question, you're like, what is that even asking? How do I do that? It seems like a ridiculously hard and obscure question. But when you think about it for a second, you think about what information we have, what information we need. We have the market demand, we have the market price. Oh, with the market demand and the market price, we can find what's the quantity demanded. And then we can find, of that quantity, how many firms we need to be able to produce it. All right, so I'm going to go ahead and stop here. The next video will pick up with this Farmer Bob video. So hope you enjoyed it. Like, subscribe, whatever. I don't know. Have a good day.